everyone. Now we'll discuss about knowledge-based agent. Okay, what is knowledge-based agent? Before that, we'll see how humans will make decisions and solve problem. Okay, human use what they know. Okay, to make decisions and problem. Similar to humans, AI agents also will store the knowledge to reason and make intelligent decisions. Okay, in which they will store the database, means knowledge base. Okay, knowledge base agent is an AI system that stores the knowledge about the world in the knowledge base. Uses reasoning to decide what to do based on its knowledge, and it also updates its knowledge as it perceives new things and takes action. Now we'll see how does it work. 3 steps in its process. One is perceive, decide, and then act. Perceives means it observes the environment and tells the knowledge base what it has perceived. Okay, first it will observe the environment and tells the knowledge base what it has perceived, means it stores the knowledge around the environment. Then it decides, it asks the knowledge base what action to take next. Okay, tell means it will tell the knowledge. Ask means it will ask how the action can be performed, like that. It will act. It takes the action and updates the knowledge base with this information. Now key components, same thing only. What knowledge base means, it stores information called sentences about the world. These sentences are written in specific language designed for knowledge representation. Okay, knowledge representation, which language is specific language. Reasoning means it uses logical rules to infer new knowledge from its existing base. Tell and ask, it's very important. These are the 2 functions it will be used in knowledge base agent. Okay, tell means it adds new information to the knowledge base. Okay, ask means queries. It will ask if any queries are there in knowledge base, will find the answers and decides the actions. Example we'll see. Imagine a robot taxi. The robot knows knows about its knowledge base that the Golden Gate Bridge connects San Francisco to Marin country. Okay, if its goal is to take passenger to Marin country, it will reason that it must cross the bridge. Okay, it does this reasoning independently of how the knowledge is stored or implemented. Okay, the knowledge is stored in its database, so using that, the robot will take the passenger to Martin country. Okay, now there are 2 approaches. One is declarative and procedural. Declarative means you tell the agent what it needs to know, like teaching it facts and rules. Okay, like some other person will teach the agents to what to do, and it guides. Okay, in procedural, you directly write the program that's agent behavior. Instead of telling, you will write in a code. Okay, that is procedural, means writing a program that says if in Francisco takes the bridge to Marin. Okay, like this. Now learning ability. The knowledge based agents can also learn. Okay, agents can also learn by experiencing and generating new knowledge on their own. It makes them more autonomous, better, and adapting new situations. This is the algorithm. See, what is the function is KB knowledge based agent. First it observes what it returns the action. Persistence, one is knowledge base and then is time. This is time. Initially it will be 0, indicating the time. First what it will do means, it will observe and tell to the database base that make percept sentences. Here sentences. Okay, it makes percept sentences. The inputs will be percept and then time. Then the action. The ask KB make action query is done. Okay, query realize what action to be performed. Then again it will tell the KB it make action sentences action T. First here it will be observed and here will perform the action. Then time will increment to 1. Then it will return the action. This is the algorithm to be performed in knowledge base agent. Okay, now we will see about the Wumpus World problem in detail. Okay, now what is Wumpus World problem is, it is a classic example in artificial intelligence. It is used to demonstrate the design and behavior of knowledge based agent. Okay, it is the design and behavior of knowledge based agent, and it's partially observable, because in that environment only partially can be seen by the agent and uncertain environment. The Wumpus World is a grid-like cave. Okay, it is a grid-like cave where an agent must navigate through rooms to find the goal and exist. Okay, here the agent should navigate through rooms to find the goal and should exit. It should get the goal and it can exist safely. The world is filled with hazards like Wumpus. Wumpus is a dangerous creature and bottomless pits which the agent must avoid to survive. Okay, first we'll look for the environment, what it looks like. Means the Wumpus World is 4x4 grid of rooms. Okay, what is Wumpus World? Wumpus World will look like the 4x4 grid of rooms. The agent starts at the bottom left corner, that is 1, 1 facing right. Inside that environment there can be 4 objects like Wumpus. It is a dangerous creature that kills the agent if they enter its room. It can be killed by shooting an arrow. Okay, pits are the bottomless trap that kill the agent if they enter the room. Okay, then gold. It is gold, a treasure the agent needs to retrieve. Okay, safe rooms, rooms with no danger. What happens is the agent needs to retrieve gold and climb out safely at 1, 1. This is the task of the agent. What it should do is it should retrieve the gold and climb out safely. The agent tools that are actuators or sensors will come. Actuators is what? Actuators means actions. Now what and all actions can be performed by agent. One, it can move forward, it moves to the next square. Turn left, turn right, means rotate 90 degree left or right. Grab means it picks up the gold. Shoot, it fires an arrow in one direction the agent is facing. Okay, shoot means it fires an arrow in direction the agent is facing to kill the Wumpus. Climb, it can exit the cave only from 1, 1. Sensors, okay, percepts what it can observe. The agent perceives the environment with the following. To be safe, these are the percepts. It can be observed by the agent. One is snatch. It can detect in the squares near to the Wumpus. If the Wumpus is there, means the neighbor squares can get the snatch. Next, breeze. Detect the squares near the pits. If there is a pit, it can breeze it. Okay, now glitter. If the glitter comes, then we can find the goal. Bump, hitting a wall. Scream, heard when Wumpus is killed. These are the perceptions observation we can write. Okay, now agent's knowledge. What it has, the knowledge means database. Okay, in database it knows the rules of the world and it knows 1, 1 is safe. Knows the agent reason. The agent explores cautiously, deducing safe moves based on the percept. For example, if it detects a breeze, it knows a pit is nearby. If it detects the snatch, it knows the Wumpus is nearby. These are the things the agent knowledge. Okay, reasons. Using logic. Same. The agent infers where dangers might be, marked potential Wumpus or pit locations, and avoids risky moves until it is confident. For example, if there is a snatch in square 1, 2, the Wumpus might be in 1, 3, 2, 2. If 2, 2 is confirmed safe later, the Wumpus must be in 1, 3. Next, the fourth one is the task environment, where we should write the description of PEAS, that is performance measure, environment, and then actuators, sensors. What we described above, just write in the wordings here. That's what performance measurements. There will be plus 1000 if we retrieve gold and exit the cave. Okay, plus 1000. Minus 1000 die, fall in the pit or get eaten by the Wumpus. Minus 10 use the arrow. Minus 1 for each move. Okay, these are the performance measure. Plus 1000, minus 1000, minus 10, and then minus 1. Environment. What how the environment will look like? It is static, partially observable 4x4 grid. Okay, in that what and all will be there? Gold, Wumpus, and pits are placed randomly. Expect at 1, 1. Actuators are forward. It can turn forward. It can turn left, right. Turn right, turn left, grab, shoot, climb. Okay, sensors, snatch, breeze, glitter, bump, and scream. Will walk through. Start at 1, 1. There will be in this it will be safe. Okay, agent can be stay safely. That is percepts can be none. Okay, that there will be no snatch, breeze, glitter, bump, and then scream. Okay, that is inference, in which statements 1, 1 and 2, 1 are safe. To move 2 to 1, the percept will be okay, the percept breeze will be there. Okay, breeze, and then none, only breeze it can find. If there is a pit in 2, 2 or 3, 1. Okay, in 2, 1, breeze if it comes, means there will be pit in 3, 1 or 3, 1 or 2, 2, like that. Okay, see, if there is a pit in if there is a pit in 2, 1, then the pit will be there in where 2, 2 and 3, 1. Okay, back to 1, 1 and then 1, 2. Okay, it will come back to 1 comma 2 and go to 1 comma 2. Their percept snitch no none. The Wumpus will be in 1 comma 3. Okay, then explore further. The agent uses logical reasoning to deduce, move safe, and grab the goal and return to 1 1. It will first stage C. It will move to here. Okay, then again it will go back and then it will go to 1 comma 2, and then again it will go to, it will snatch the goal and then it will come back. Once again I will teach you. See, first the agent will be in the square, this square 1 comma 1, then it will move to 2 comma 1. Here it will be breeze. What it thinks is in 2 comma 2 and 3 comma 1 there will be pit. Then again it will go back to 1 comma 1 and then it will move to 1 comma 2. Okay, here snatch will be there. Snatch will be there means it can find that in 1 comma 3 Wumpus might be there. So biologically it will think, and then in the next step it will move to 2 comma 3. Here it might find all breeze will be there, that is snatch will be there, glitter will be there, and then breeze will be there. So it will find out glitter is the gold is there, then it will think and then it will grab the gold and it will move back to the this 1 comma 1 square, then it will exist. Then the agent done its work and then it will move back, then the game will complete. Explain propositional logic, syntax and semantics with suitable example. We'll see the syntax of propositional logic. The syntax of propositional logic: atomic sentences and complex sentences, operator precedence, and then example. Okay, the syntax of propositional logic specifies how sentences are formed. There will be two sentences. One is complex sentence and atomic sentences. Complex sentences are single proposition symbols like P, Q, R. Okay, P might mean like it is raining or it is dancing, something. In complex sentences means built from atomic sentences and uses logical connectivities. Logical connectivities, there are like 1, 2, 3, 4, 5. There are many types are there. We'll see. Okay, complex sentence, negation. Okay, negation is not. Example, negation P means it's not raining. Conjunction is and operator. Disjunction is or operator. Implication is if then. Biconditional means if and only if. There are 5. Okay, negation P, it is not raining. P and Q means it is raining and it is cloudy. Or operation P or Q means it is raining or it is cloudy. Implication, if then. Okay, now if then. P implication Q means if it is raining then it is cloudy. Bidirectional is if and only if. If it is raining, it is raining if and only if it is cloudy. Okay, this is operator precedence. This is the order of evaluation. Okay, negation and or implication, and then biconditional. A sentence C, not negation P and Q or R. It is not raining and either it is cloudy or the ground is wet. Now we'll see semantics. Semantics defines the truth of the sentences based on a model. Okay, it is defines the truth of the sentences based on the model. Atomic sentences, their truth is directly given in the model. P is equals to true. It is raining is true. P is true, then it is raining is true. Complex sentences uses truth tables to complete. First you should write PQ. Okay, what is or operation? No negation. What is not operator? Not P means the true means false. Okay, your true, again your false will be there. Your false, then your true will be there. False, true. Then again this and this done. P and Q and operator. If there is one true, then output will be both 1 1 means both true means the output will be true. Okay, see, true true true, then all will come false. Or operator, if one is true then it will be true. True true true, true false true, false true true, then false true false. This is implication. Okay, true true true, true false false, false true true, false false false. Okay, if there is true false then it is false. This is biconditional. Is if there is both true true and both false false, then it will be true and this both will be false. Okay, true false false, false true false. Examples, this is sentences. This then model P is equals to true, Q is equals to false, R is equals to true. Compute, negation of P is false. Then compute this. We should do like this. Then the sentences is false. That is P is true means negation of P is false. Okay, then Q is false. False are true, you will get true. Then if you combine all this means there is AND operator. and operator. Okay, false and true, we will get false. That sentence is false. Now this is important questions, they might ask for 10 marks. Okay, we should prove that that Wumpus is in the room 1,3. Okay, see, considering Wumpus, for example, give the characteristics and simple knowledge base using propositional logic and prove that Wumpus is in the room 1,3. Same what we discussed about Wumpus World, we'll write once again. See, we will discuss the knowledge based representation and the method to find the Wumpus using propositional logic representation. Okay, first from the following figure that shows the agent has reached the square 1,2. Okay, after reaching, see, it will be there in 1,1, then it will move to 2,1. Here it will find out that pits will be there. Okay, because of breeze find in 2,2, and then 3,1 it will find there will be pit, then again it will go back to 1,2. Here the snatch will be formed, so Wumpus it might be in 1,3, it will find out here. So this table you will write. Then you should write about knowledge base. What is knowledge base? The agent pursuits are converted into sentences and entered into the knowledge base with the same valid sentences. We will write this, and we have, okay, now from the table we can write that in this table we can write what is there will be no snatch 1,1. Okay, in snatch, in which one will not be there. Snatch will be there only in 1,2, and then 1,4, and then 2,3. Okay, see, for the square 1,1, snatch won't be there in 1,1, and then breeze won't be there in 1,1, so there will be negation of S11. This S is snatch and B is breeze. Okay, then in the square 2,1, in the square 2,1 breeze will be there. In the square 2,1, there won't be snatch and there won't be breeze. In the square 1,2, there will be a snatch and there won't be a breeze. Okay, all the conditions you will write. You should know about these 3 rules. Okay, that is S11, S21, and then S12, negation of S1, negation of S11, negation of S21, and the negation of S12. See, wait, we will see in negation of negation of S11, here in negation of S11, if there is not, snatch won't be there in 1,1, then Wumpus won't be there in 1,2, then 2,1. Okay, that we will write here. Yeah, if there is no snatch here, then Wumpus won't be there in the square 1,1, 1,2, and then 2,1. That only we wrote. Negation W11, negation and negation 12, negation of W21. Okay, this is rule 1. And if the snatch is not there in square 2,1, in the square 2,1, if there is no snatch means Wumpus won't be there here. Okay, then here Wumpus won't be there. Okay, so negation of W2,1, negation of W2,1, negation of W11, negation of W22, negation of W31. Okay, like this we will write. The negation of S12 here. If there is no snatch, if there is no snatch in 1,2. Okay, now we are considering this. If there is no snatch in 1,2, then Wumpus won't be there here, and then here. What those are? That is negation of W12, W11, W22, and W13. Okay, then negation of S12. You will write all this, where and all will be not there. Okay, why here R means a negation of 1,2. Like it might be there or it not be there. So in 1,3 there will be there Wumpus, so it will write. Okay, now by using the inference rule we will solve this. First we will take the modus ponens with negation S11 and R1. this we will take. Okay, S11 this full, here S11 gives to S11 gives to this, here R1 will be, okay, this will be A and this will be B, and again A to B comma A. What we will get? Only B we will get, so only this part we will write. Okay, negation W11 and negation W12 and negation W1. Now we will do AND elimination, means we will remove this AND operator. Okay, after removing we will get negation W1 comma negation W12 negation W2, and again we will apply the modus ponens to negation S12 and R2. For this we will apply, then again only this part we will get. Okay, that is W22 negation W22, and like this we will get. Again we will do AND elimination, we will remove the AND. Simply we will get negation W22 negation W21 negation W31. Then for this modus ponens to S12 and R4 to obtain. What we will do? We will do modus ponens will get this one, and again we will remove AND operator. Then we will get this 1 to apply mod ponens to S12 and R4 to obtain. Okay, with it, and we got as W13 or W12 or W22 or W11. Okay, we will do the unit resolution on with this and negation 11. If you do unit resolution, then W11 will get cancelled and will be remaining this. And again for this we will do unit resolution for W22, then this and this will get cancelled, again will remind W12 or W12, and again we will do unit resolution and will cancel W12 and negation W12, we will get the W13, and this is proved Wumpus will be in the square 1, 3. Okay, using this inference rules. Thank you guys.